Hello and welcome to Learning Space. I am your host, Dr. Pamela Gay, and I have to say a special thanks to Andreas Plazas for covering for me rather last moment on today's Daily Space. As sometimes happens, I had something come across my desk and he graciously stepped in. Now, we are going to switch from talking about today's news to talking about not quite tomorrow's, but a not so distant launch. I have with me today Yoav Landsman, who comes to us from SpaceIL. He is an old friend of CosmoQuest and a dear friend to me, and hopefully the moon is going to become a dear friend to his spacecraft. Welcome, Yoav.
Hi, thank you for having me here.
So, Learning Space is a show where we ask people to tell us their stories and how they got to doing these crazy and amazing and awesome things that you're doing. Now, before we get to your story, can you fill everyone in on what exactly it is you do and what SpaceIL is?
Okay, um, maybe some of you remember the Google Lunar XPrize, which was a competition in the last several years until last March. It's an XPrize competition to put a privately funded spacecraft on the surface of the moon, take pictures and sending them back and videos, and get to the moon is hard enough. And SpaceIL is the only Israeli competitor in that competition. And I'm not sure, but even though the competition is over, we may be the only group that is still working. And we're going to launch our spacecraft this year, this December. And we're going to land on the moon in February.
And this is really an amazing journey you guys have been on. Moon Express, Astrobotic. It's not biology,
Right.
it's astrobotics for robotics. Are both saying that they haven't pulled out yet, but your team is the only one that I know of that's currently berthed. And the original competition was get to the moon by any means possible, hop, flit, dance, dig, burrow, fly, go 500 meters, and then send
Wormholes.
back. What was it?
Wormholes.
Yes, wormholes. Wormholes would be a great way to do it. And then, however you got across the surface, send back an HD video of
Yes.
of the moon. And this competition launched shortly after the success of the Ansari X Prize that was won by Space Composites, which has transitioned over to working with Virgin Galactic. And they upped the stakes from low orbit or suborbit, as the case may be, to let's skip low Earth orbit altogether and go straight to the moon. Now, you weren't there from the early days. When did SpaceIL get involved, and when did you get involved?
The competition started on 2007, if I remember correctly. And we joined the competition very late, at the end of 2010, which means it was actually the last day of registration. And we started then, and we evolved through the years because we had a lot of it's a tough challenge.
Yeah.
At the beginning, we thought about very small spacecraft, but reality showed us that you actually can't do that with very small spacecraft, unless, of course, you have a ride to the moon. Because if there were rockets that can get you to the moon, and then you only need to get down and land, it will be much easier. But there aren't. So we have to have a launcher that will take us into orbits as a satellite. And from there, we have to carry our own fuel to the moon in order to bring ourselves to the moon, which means you need a much larger spacecraft in order to get all this fuel. And the larger you are, the more mass you carry, you need more fuel to propel yourself, which is the paradox of everyone that is working with the missiles and rockets and
well,
spacecraft.
it's this problem of if you double the height, the volume goes up as the cube, so it's 2 times 2 times 2, so you have 8 times the mass just by doubling the height.
Yes.
And that's a lot.
So we had the troubles then, and then we had to start and redesign several times. And did you hear me?
You're still there. You're still there.
Okay, I thought there was a glitch. And I joined the group in 2013. It's actually almost exactly 5 years from now. And we had to. When I joined, we had a very tough decision about with which rocket, with which launching company we're going to get into space, because we tried to figure out how to design a spacecraft that could fit into any kind of rocket in order that to have the opportunity when you have the opportunity to get a contract with anyone, then we can jump into it and sign.
And this is one of the huge problems that has faced all of you with the Google Lunar XPrize. When this competition started, we still had the space shuttle. And SpaceX wasn't really a thing yet. I mean, it was a thing, but it wasn't a launch every week kind of reusable, could already land on the ground. All these new companies that are out there, all these new rockets that are out there weren't here, and we had the shuttle. How has it been watching all of these changes going on, and you're like, please just take our spacecraft?
It was a very exciting time, because it's not all the new space, the CubeSats and the student satellites and all these cute little spacecraft weren't there yet. There were very, very few of them, and if you had a private spacecraft, you couldn't just ask the space shuttle people to bring it into space. It's not like that. It wasn't established yet. Now there are some companies, some business companies that can do it for you, or you can send it with a supply ship to the International Space Station, and then they're dropping it outside and into orbit. But then there wasn't any clear way, any simple way to do that. Not that it's very simple now, but unless you're actually a CubeSat, which is a standard spacecraft, satellite, if you're not that, then you need to get your own launch, which means to sign contract with a specific company and deal with it and to design your spacecraft to that rocket with its environmental conditions and all the vibrations and shock and accelerations, which are very very specific for this kind of spacecraft, because you can design something that will fit every rocket until there are standardized rockets, which probably will never be.
So I've brought up the video that you have up on your website showing the procedures. Now, one of the things that we've become used to working with NASA spacecraft is they will often do a launch and done. You launch on your way to Mars. Quite often, it's you are just gone. You are gone. We have occasional missions that will put themselves in Earth orbit and then fire a few times to get into an elliptical orbit. But with a lot of these missions, we want to fully utilize the rocket fuel and that extra boost that you can get by going straight to the needed orbit. But since you guys are sharing a berth, you can't just go straight to the moon. What is the crazy and amazing pathway that you'll be taking from your December to launch to your when arrival?
We are going to land on February 13th because we know when we're going to land, and we know the phase of the moon when we're going at the date we're going to land. So the landing is very specific, and since we're a secondary payload on the rocket, then the launch is not entirely it's not our launch.
So it could launch a little bit later, and you still have to make it work.
Exactly. So if we're going to be launched a bit later, or a few days, or even a week or two later, then we still have to do everything in time in order to get to, at the same date to the moon. And it's possible. It's just a matter to adapt. And we're going to be separated, injected into a high elliptical orbit, like orbit of some geostationary satellite. And from there, we have to correct the orbit and to increase the height of the apogee, and in several steps. Until the height is like the height of the lunar orbit. And when we get to the apogee on the lunar orbit, we need the moon to be there. So
yes,
every correction every orbit correction during this series of maneuvers have to take into account where the moon is, and to get us exactly to the right place at the right time when the moon is there. And then we have to, when we get there, we have to perform another maneuver in order to capture lunar orbit, which is funny because it's the other way around. The moon is capturing us, and then we're in lunar orbit, which will be amazing to achieve even that. And then we have to orbit the moon until we have the right conditions for the landing, which means when we are at the right height above the landing site, at the right phase of the moon. And then we're going to use our own propulsion system, our own engines, the same engines that got us there, and land in the Sea of Serenity.
That's just amazing. And I love the way that because you can orbit for free, once you get yourself up into a high orbit, as long as you get up there ahead of time, you can just hang out, go around the Earth a few times, yes, as many times as are needed for the moon to get where it needs to be, so the two of you will end up at the same spot at the same time. And it's that ultimate dog trying to catch the frisbee problem of, is the wind going to catch the frisbee? Well, you don't have wind, but you do have orbital mechanics. It's true, you do have that. Now, this must be an amazing time for you. Are you going to get to go to the launch? Or are you going to be controlling the spacecraft from behind somewhere?
I'll probably not going to see the launch. I've been in several satellite projects in my career, and I'm always at the mission control center. But I actually never saw a launch.
Oh, jeez. Well, I've never seen a solar eclipse, so it's okay. We'll trade.
I'm so sorry.
I've seen launches, though.
Yeah, but those clouds.
For full disclosure, for those of you who weren't there, Yoav and I were at the same site, but a few 100 meters apart during the August eclipse, and he saw eclipse and I did not. But I've seen spacecraft launches. Now, one of the things that's awesome about SpaceIL is, while you're there working so hard to make sure, as rocket scientists do, that your rocket sciences and you get a rocket that goes to the moon, you also have team members. I see Ambias, who's Elad Avran, in our chat, that are working to communicate out. What all have been the things that you've done with SpaceIL? Because you will be the first non-governmental agency and a new nation to get to the moon. What are you doing to make people know, hey, Israel does space too?
You froze at the last part.
Oh,
so
sorry. I said Israel does space too.
Yeah. SpaceIL, from day one, our founders had this idea that even if we win the competition and land in the first Israeli spacecraft on the moon, the first private spacecraft on the moon, and no one hears about it, it will be for nothing. It's a waste. And they had this idea of leveraging this tremendous effort into inspiration for, especially for young people and for the public, and to do a lot of educational programs and outreach, and inspire young people to choose STEM studies, for example, and to show people that there are good news sometimes here, because we will have lack of good news lately, and to show that we can do impossible things, because it looks impossible to get to the moon. But we're going to do it, and we're going to try to do it anyway. And in the educational department, we're doing a lot of work. We have a large group of volunteers that go to schools, to kindergartens, to workplaces, and everywhere, in order to tell the story and show what we're going to do and answer questions. And we get a lot of very good response. We have some more professional educational activities. We even got into the physics final exams in schools, the national final exams, and we're doing a lot of projects with other groups, with other companies, educational companies, in order to maintain this, in order to achieve continuity, because we're going to land on the moon in February. We need to help the idea to stay.
Now, this isn't your first spacecraft. You've been a rocket scientist since you started college, basically. Now, what
finished.
what has been your career that has gotten you to this point?
Okay. First of all, I chose to study aerospace engineering, mainly because it's interesting. I love the airplanes and spacecrafts from, I don't know, from days back. And and it was an opportunity. But then I didn't know much about what you can do with that in Israel, because although the space industry in Israel is not new. We have a lot of spacecrafts for this size of country. We have more than 10 active satellites in orbit right now, which are altogether Israeli. They're designed here and operated from here and assembled here. So it's but it's something that people don't know much about, which is a shame. And after I finished the engineering school, I went to work there, and I worked on the Amos communication satellite, and which is designing and operating the spacecraft. And then after a while, I got a job at the same company of being the chief systems engineer of Amos 6. But then I started the project, but I felt that I don't want to stay there. Because of the environment, I want to do something else. I wanted to do much more outreach and education. I went to the university for a second degree, which was in geophysics and planetary sciences, which is very different from engineering, but I found it very good combination of engineering and science together. And then in 2012, I quit. I quit my day job, and I started giving lectures and classes just to spread the word. It gave me a very good feeling to tell the story, to tell people what is out there.
Now, one of the things that I deal with is I'll talk to people about different spacecraft, the InSight mission on the way to Mars, and people are like, oh, NASA still does things? We didn't think there was still NASA now that there's no longer a space shuttle. I get that less and less, but it's still a feeling. Now, I'm at least coming from a perspective of people knew about American space. How often do you tell people what you do and they're like, wait, what? Is this
all the time. People just don't know about what's going on here.
Yeah.
Probably because the first satellites in Israel were military satellites. So it's all under secrecy and stuff. But we're doing civilian satellites now. There are student satellites. There is a scientific satellite, and cooperations with other agencies. So there's nothing to hide there, and people should know, because in the end, people need to know what their tax money is paid for in the governmental agencies.
Yes.
And I think that now we're at the beginning of a very, very good era.
Yes.
Of a lot of high-tech companies and startups that are doing space things, and some of them are beginning to gain success, and some of them are just at the beginning, but some of them will succeed, and it's very exciting. It gives a lot of opportunities for young engineers and young scientists to do stuff in this area, which is a very exciting thing to do. It's not ordinary in any way. A lot of departments in universities are giving classes and projects that involve space, and it's just the beginning. That's my feeling, at least.
That's amazing. And with SpaceIL, you are planning where you go, what you do in the future. Is your first little craft going to have any scientific capabilities, or are you looking mostly in the exploration side of things and checking your tech?
You ask about our spacecraft?
Yes. So sorry, let me say it differently. Will your little spacecraft mostly check out technology, or do you have any science that you'll be able to do?
I think that if I have to classify our spacecraft, then I would classify it as a technological demonstration, because it's going to be the smallest spacecraft that ever landed on the surface of the moon. And it has a lot of innovations in it, in a lot of ways, and a lot of new capabilities for this size of a spacecraft and a private spacecraft. But we, in addition to that, we felt that we need a scientific equipment to do something for the benefit of humanity, to add something to the human knowledge, and we chose a small device to study the magnetic field of the moon. It's a magnetometer that was made by UCLA. And actually, I believe that a twin of that instrument is on the InSight mission.
Oh, that's awesome.
Yeah. And the lunar magnetic field is very weird. It's not global in any way. It means that you have local magnetic fields around the moon. And we're trying to land in a place which is both very the best place to for a safe landing, which there are not many places like that, which has a magnetic anomaly nearby, because these magnetic fields, these local magnetic fields, were not studied very well, because they are local. You have to get very close to them in order to measure them, and you can't do that from it in a good way.
I just brought up a picture of one of these lunar magnetic swirls. These are regions on the moon where we think that because of this random localized magnetic field, and I say random because we haven't found a pattern to where they're located, the magnetic field is able to change how the dust and debris settles out on the surface, creating these amazing features.
Yeah, and it can teach us about the origins of the moon, and then it's important to study this phenomena, and you can do it actually only in two ways, or by a very low approach, which probably means during landing, and on the ground. But we can't explore a lot of distance on the ground, so we're going to take measurements during the landing and on the surface for some time, because maybe there will be a change in time. We don't know. This is the scientific contribution of this mission.
That's kind of awesome. Now, this is all just a start, and I wish you so much good fortune. And in general, I have to admit, spacecraft are dead to me until after they've successfully gotten where they're going and started sending back data. But I have been eagerly following along with what you're doing. Now, I do have people discussing in the chat, once upon a time your mission was going to jump across the moon, essentially. What are you doing today? What is your new updated plan?
After the competition, practically.
Yeah, exactly.
It actually means that we're not bound to the rules of the competition.
Right.
But we designed the spacecraft and every feature of the spacecraft for these competition rules. So we actually have a choice whether to follow them or not. So we actually, bless you, we actually have, we will have to decide after we land, if we see that we land safely and everything is operational, where and to what distance can we hop? We are a hopper, so we can do that. So we'll have to decide if we're going to do that or not, because obviously we're not going. We may not want to crash on the hop after we landed successfully, because when we have this first spacecraft on the surface of the moon, it's like a heritage site. You don't want to touch it.
Yeah.
So I'm not sure about that. It's also not an engineering decision.
Right.
But we'll see. We are perfectly capable of doing that.
That is
of doing the hop.
That is amazing. And as you're gearing up to do all of these amazing things, you were inspired by the people of the past, by the spacecraft of the past. What are you hoping this will open up the door for future people to be inspired to do?
Wow. I think we can inspire people into entrepreneurship, to invite new things, to dare to do huge things, impossible things. We hope to inspire young people to be able to dream, to do stuff like that. Because I remember as a kid, you couldn't just be an astronaut. There was no possibility of doing that if you're born in Israel.
Yeah.
At least you couldn't imagine of doing that, or to be a part of a huge project like a spacecraft or something like that. But here we are. It's possible. There was an Israeli astronaut, and we're building spacecraft. So these things are possible, and we hope that people will take that as a demonstration that things are possible, even though at first glance it looks out of this world.
Do you ever still feel like little kids trying to buy a Lamborghini with a lemonade stand?
Sometimes, yeah. I think it's well, yes. Yes. Yeah, it feels like we're trying to push ourselves into the adult business. You know what I mean? Because landing on the moon is something that superpowers do.
Yeah.
Not there are only a few companies, a few countries that can launch into space and to create um, a new spacecraft out of ideas.
Yes.
And we can do that today. And we try to push ourselves into deep space, to the moon and to other places. As I tell people at the office, if we, for some reason, decide that we don't want to land on the moon after we are in space, we have enough fuel to get to Mars.
Really?
Really, because most of the delta V is just getting into space.
Okay. So
So
do you have a twin spacecraft that you can launch in the not too distant future?
it's not that simple, because if we're going for lunch, we can't communicate with a spacecraft, for example. Okay, but the foundations are there. Okay, we're doing the first step into deep space, and our successors, or maybe this organization will adapt to another very influential mission.
That sounds amazing. And do you think that the work that you and the other teams have done to pioneer everything from 3D printing to lower cost testing facilities will make it so that in the future it's not students dreaming of space, but students building robots that go to the moon in their robotics class?
Why not? Why not? There are already students that build robots, right?
Yeah.
So and other students build spacecraft, and there are a lot of other projects in computing and other kinds of technical fields. You can do that. You can actually do that. It's mostly a matter of money, of how to fund things. So if you can, and this is also why we go to the public. If we get enough power from the people, we can it can open doors and get money from the municipal people or from the government, in order to have these kinds of projects.
That sounds amazing. I have people asking, what would a second probe cost if you just rebuilt what you have now?
I'm sorry, I couldn't hear you.
Sorry, my internet glitched. What would it cost to build a second one and go to Mars?
Wow.
You don't have to answer.
I'm not sure, because I'm not very good with money.
Fair. You're an engineer. This is why they don't let us price things.
It's not something I'm very interested in. So the money. I'm very interested in Mars. So if some project like that comes along, you can count me in.
I think that is a great way to end it. This has been fabulous. Do you have any places that you would like to send people to learn more about you and what SpaceIL are doing as you journey to the moon?
First of all, we have a website, and you can find a lot of material there. You can find me on Twitter. I'm with the handle Massacritids, which maybe sounds weird because it's in Hebrew. But if you type Yoav Landsman, you can find me there.
And SpaceIL is on Twitter as SpaceIL Team.
Yeah, and we have a YouTube channel, and I'm in the internet.
And folks, I strongly recommend you go find SpaceIL and find Yoav and find out just how it is that everyday people, admittedly with space rocket degrees, are getting us to other worlds in our solar system. This has been a really great discussion, and thank you everyone in the chat for bringing the questions and being here to hang out and learn more about space exploration. We will be back on this channel tomorrow. It will be me bringing you your daily space at 1 p.m. Eastern, 10 a.m. Pacific. That's 6 p.m. London time. So I hope to see you then, and until then, we are part of CosmoQuest, and we invite you to be part of exploring other worlds. Join us at cosmoquest.org, and we have a particular data call right now for the Mars and Mercury mapping projects. So please check it all out. If you like what you see, give us a follow, and you'll get notified every time we go live. We are sustained through your subscriptions, and every bit really helps. Thank you so much, and Yoav, this has truly been a pleasure. Thank you so much for being at work now past 9 p.m. to be part of our show.
Thank you so much.
And thank you, everyone, wherever you are in the world. Have a fabulous morning, evening, or afternoon, and remember to look up. Bye-bye.